Hey everybody, Automan here again. Just testing out one of my new motor creations here. These are the 2-volt meters. One of them on the left is showing 1246. That's the input battery voltage, the main input battery. And the other one is showing approximately 0.97, almost 1 volt. That's the actual voltage contained in the saltwater copper aluminum foil battery tube that I'll show you in just 1 second. The motor seems to be working real nice now with the new wheel. I have a couple of circuit modifications I did to it. Bring the camera over here. Alright, right there. What we have there is the output of a standard single filer pickup coil running to a standard joule thief circuit with a 2N2222 transistor with a 100K resistor to a 38 turn bifilar toroidal 1-inch coil. The output of that is leading to a I believe it's a TL7668 charge pump chip, and that works very nice. Multiplies the voltage by 2 using a couple caps and a couple diodes. So we're ending up getting about maybe 20 volts out of that guy between those two circuits. And we're pushing that into a 1500 microfarad 40 volt dump cap. And then we're using a Velleman relay timer with a 555 circuit that I had laying around. So we're using that as a cap dumper, cap pulser, and we're charging it on the normally closed side and dumping it into the saltwater copper aluminum foil battery on the other side, the normally closed side. And it's being powered, the source, off of the 12 volt run battery there, which is a lead acid golf cart battery, about 100 amps. The drive coil on the motor over here. Let me zoom that out a little bit for you there so you can see the whole thing. Yeah, this is a pretty interesting circuit we got going right here. It's actually one transistor, PNP transistor, no resistors, no diodes, hooked to a 400 turn 26 gauge 1-inch by 1.5 inch long coil with one welding rod core. That's hooked up to a Honeywell AS400 series unipolar Hall switch, and there is a 1 neo magnet, 5/16 diameter neo magnet, about a 1/2 inch away from that, maybe 3/4 inch away from that Hall on the back side, which according to a user on one of the forums actually gives higher RPM by increasing the pulse over the coil, which I can attest to you that it truly does. Gives you about a 30% increase in RPMs and lessens the amp draw on the motor. So far I've only used about a little bit less than a volt in about 3 days worth of on time. So it's a pretty efficient motor. Has a 3/4 inch HDPE cutting board wheel with two 5/16 bearings from PC Fan, and spring loaded on a shaft. And the pickup coil over there is about 200 turns 26 gauge on a single steel nail, and that puts out about around a 1/2 volt, 3/4 volt at full RPMs AC. And we're using that through a diode and a capacitor as kind of a crude half-wave rectifier setup there, and then that feeds the joule thief at about maybe 3 volts, and then it gets fed in from that 3 volts. The joule thief gives it about 6 or 7 on a good day, and then that 6 or 7 goes into the input of the charge pump circuit, the TL7662A charge pump circuit there, and that gives approximately 15 to 18 volts depending on what it feels like doing that day. And then we're running that out into the dump cap, as I said before, and then that's being pulsed into the salt water copper penny tinfoil paper towel battery there that you can see, which actually holds about a volt, so it's very, I think I'm going to explore that some more and make some more of them. Get some rolls of pennies from the bank, put them to good use. Anyway, I just thought it's kind of a curious circuit there. It's only two coils, one single transistor, no pots, no resistors, no diodes, straight Hall switching, 4 neomagnets embedded into some cutting board material there. So I thought it's a pretty interesting circuit. You guys might want to check it out. So anyhow, Automan out.